A machine puts liquids into bottles of perfume. The amount of liquid put into each bottle, d millilitres, follows a normal distribution with mean 25 millilitres. Given that 15% of the bottles contain less than 24.63 millilitres, part A says we need to find to 2 decimal places the value of k, such that the probability of d being between 24.63 and k equals 0.45, and this is for 5 marks. Okay, so I'm going to start off by going through and writing down what we know. So we know that the random variable d is normally distributed with mean 25 millilitres, and then we don't know the standard deviation. Also referring to this line here, we see the probability of d being less than 24.63 equals 0.15, because that's 15% as a decimal. So that's what we know so far. And before we get on to the next bit, we need to essentially work out what sigma is here. So work out what the standard deviation is, and then we can move on to the next part. So the way we can do that is referring to this here. So here I've got the standard normal distribution, and we normally represent this with the letter z. So you see that z is normally distributed with a mean 0 and standard deviation of 1. So we can use this and this in conjunction to work out what sigma is here. So using the standard normal distribution, we're going to write this. So we're going to say the probability, and this time we're going to use z, because we know z is defined over here, and is less than. And then we're going to match this part up with this over here. What we do, okay, so we're going to use this number here as our x here. And we already know, because we've been told in the question, that mu is going to be 25, so we can replace that. And then we don't know sigma, and that's what we're trying to work out, so we're just going to leave that as sigma. So we're going to get 24.63, take away mu, which we know is 25, all over sigma, which equals 0.15. So now what we can do is use our inverse normal mode on the calculator. In inverse normal mode, we're going to make sure tail is set to left if the calculator lets you choose that. If not, don't worry. Then we're going to select area to be 0.15. And because here we're using the standard normal distribution, we're going to set sigma to be 1 and mu to be 0. Then we're going to click enter and see what we get. So we get minus 1.0364. So therefore, we know that 24.63 minus 25 all over sigma equals minus 1.0364. So this is great now we've got to this point, because essentially we've got an equation with one unknown, which is sigma. So we can just solve for this and work out what it is. So we're going to multiply both sides by sigma and divide both sides by this number here. We're going to get 0.357. So therefore we've now got enough information to write out the full distribution. So we say d is normally distributed with a mean of 25 and a standard deviation of 0.357 that we just worked out. So now we've done all this work, we can look back at what part A wants us to find. So we need to find to 2 decimal places the value of k, such that the probability of d being between 24.63 and k is 0.45. Now quickly, to help visualize something, I'm going to draw a line here. And if I label on here, so let's say this is 24.63, and here's k. This is the area that we want. But we want to think about if there's any other way to write this. So what we could do is write the probability of d being less than k, because that's going to be all of this area here. Okay, so we've covered the right area, but we've also got this little extra bit, so we need to take this away. So I'm going to take away the probability of d being less than 24.63. So hopefully that makes sense why that is equivalent to all of this. So again, this is going to be equal to 0.45. However, from earlier in the question, we found out that this, if we look up here, is actually equal to 0.15. So we can replace that with 0.15 equals 0.45. So the probability of d being less than k equals, so if we add 0.15 to both sides, we get 0.6. Then we're going to work out k using inverse normal on our calculator. However, this time using what we worked out here, so that mu equals 25 and sigma equals 0.357, and setting the area to be 0.6. And that gives us 25.09 to 2 decimal places. And this right here is the final answer. So we get our first mark here, so getting down to this part using the standard normal distribution. And then we got a second mark for rearranging that and getting the correct value for sigma. We got a third mark for this line here, so saying the probability of d being less than k is 0.6. Then we get 2 marks for the rest of our working, so getting down to k equals 25.09. So moving on to part B, a random sample of 200 bottles is taken. And part B says we need to use a normal approximation to find the probability that fewer than half of these bottles contain between 24.63 millilitres and k millilitres. And this is for 3 marks. So now firstly we're going to think of this as our binomial distribution. So we're looking at whether bottles contain between 24.63 millilitres and k millilitres. So a bottle is either going to satisfy that, so going to be between these values, or not. So there are 2 possible outcomes. So we can think of this as a binomial distribution. Right, so if we say y, so that's distributed binomially, with n being 200, because there's a sample of 200 bottles, and p, so the probability. If we look back up at part A, we can see the probability of it being between 24.63 and k is 0.45. So we're going to have 0.45 here. Now, with regards to a binomial distribution, we know that the mean is n multiplied by p, and the variance is n multiplied by p multiplied by 1 minus p. So doing that, the mean is going to be 200 multiplied by 0.45, it's going to be 90, and the variance is going to be 90 multiplied by 1 minus p, so 49.5. So we can then use this to write a normal approximation to the binomial distribution. So we can say y, which is distributed binomially here, so it is approximately distributed, we're going to call it w, with a normal distribution, and we're going to put the mean and variance in here. So that's 90 and 49.5. And look back up the question. So it's a random sample of 200 bottles, and we want to find the probability that fewer than half of these bottles contain between 24.62 millilitres and k millilitres. So fewer than half will be less than 100 because it's a sample of 200 bottles. So probability, and working with y, we've got y is going to be less than 100. And it's going to be approximately equal to the probability that w is less than. Now here we're going to need to use a continuity correction because we're modelling a discrete distribution with a continuous distribution. So it's going to be less than 99.5. And now we can work out this probability on our calculator. So going into our normal CD mode on our calculator, we're going to set the lower to be a really low number, so I'm going to do minus 1000. We're going to set upper to be 99.5. Then we're going to set mu to be 90. Then we've got to be careful here because we've got 49.5 here. However, this is the variance, and in the calculator we need to put the standard deviation. So we need to put the square root of 49.5, and we get 0.9115 ... which equals 0.912 to 3 decimal places. So you get 1 mark here for this line, and we get a second mark down here, so for implementing the continuity correction. Then we get the third and final mark for the correct probability of 0.912. So lastly, take a look at part C. The machine is now adjusted so that the standard deviation of the liquid put into the bottles is now 0.16 millilitres. Following the adjustments, Hannah believes that the mean amount of liquid put in each bottle is less than 25 millilitres. She takes a random sample of 20 bottles and finds the mean amount of liquid to be 24.94 millilitres. And part C says we need to test Hannah's belief at the 5% significance level and stating our hypothesis clearly. And this is for 5 marks. So first we're going to state our hypotheses. So our null hypothesis, so H0, is that mu, so the mean, equals 25. So we're referring back up to this line here, where it says that Hannah believes that the mean amount of liquid put into each bottle is less than 25. So for the null hypothesis, well, we're going to assume that it's not less than 25. We're going to assume that actually it is 25. And the alternative hypothesis is what Hannah believes here, is that H1, so that the mean is less than 25. Now we're going to get some other information that we need. So we've got a sample of 20 bottles, and the mean amount of liquid in the sample is 24.94. So we say, okay, so we've got n equals 20, and we've got the sample mean to equal 24.94, and we see we're testing at the 5% significance level. So first thing we're going to do is we're going to assume that the null hypothesis is true. So assuming that's true, I'm going to use the random variable d, because we're talking about liquid measured in d millilitres. So d is normally distributed, and assuming that H0 is true, that's going to be 25. And looking back up in the question for the standard deviation, we can see, okay, so that's now 0.16. So it's the standard deviation 0.16. We need to remember that it's squared, which gives us the variance. So assuming that H0 is true, D is distributed normally with a mean of 25 and a standard deviation of 0.16. So now we know for a random sample of size n taken from a random variable, and here we've got x, which is normally distributed with mean of mu and standard deviation of sigma. The sample mean, so x bar, is normally distributed, again with the same mean, however with the second parameter, so the variance, being the standard deviation squared all divided by n, so the sample size. So doing that in our case, because we're using the random variable d, so the sample mean is going to be normally distributed, and we're still going to have 25 as our mean. And then for the second parameter, we're going to have 0.16 squared, all divided by our n, which is 20. So now what we do is using this, we're going to say, okay, so the probability, d bar, being less than the sample mean, so 24.94, and we can work that on our calculator using these values here. So we're going to go to normal CD. We're going to set a really lower value, so I'm going to say minus 1000. We're going to set our upper value to 24.94. We're going to set our mu be 25, and our sigma, so we need to remember to square root this. So our sigma is actually going to be 0.16 divided by the square root of 20. When we press equals, we get that to be 0.046766. ... So now we're going to compare this to the significance level. So if I round this, I'm going to say, okay, so therefore, I can say 0.047 is less than our significance level of 0.05, so 5%. Therefore, now I'm going to write a little conclusion. Since it's less than our significance level, we can say, okay, so we're going to reject the null hypothesis. There is significant evidence to support Hannah's belief. So to support the fact and say yes, it is likely that the mean amount of liquid put in each bottle is less than 25 millilitres. So we get 1 mark here for our hypotheses. We get another mark here for defining the distribution of the sample mean. We get a mark here for working out this probability. We get a mark for this part here, so saying our probability that we just worked out is less than 0.05. And we get a final mark for a concluding statement wrapping all together.